So I'm going to show you how we're going to do the demo using gold nanoparticles as sensors for electrolytes and sports drinks. So when you arrive at the table, when a visitor arrives at the table, there's going to be a vial that is our standard vial of gold nanoparticles, which you'll see right here. And then we're also going to have our electrolyte solutions. We're going to have multiple electrolyte solutions. Here we see we have our Pedialyte and our Gatorade. We're also going to have our container of our gold nanoparticles, which we'll be using to test for electrolytes and sports drinks. Then we'll also have some vials, which we'll be using to do the tests, as well as having some pipettes and materials to clean the vials when you're done. So when someone arrives at the table, what you're going to do is engage them, say hello, obviously as you would with any demo that you're doing, and ask them if they want to learn a little bit about which sports drink would be the best sports drink for them to use when they are outside running around, exercising, whatever, playing tennis, whatever works for them. It's a way to engage them, and then we're going to say, well, we're going to show you a way to test this that's going to be a little different than what you may have seen previously. We're going to use nanotechnology to test this. And in particular, we're going to use gold nanoparticles. So what we want them to do is to pick two different electrolyte solutions to decide which one they'd want to take if they were dehydrated. In this instance, we only have our Pedialyte and our Gatorade, so we're going to test those two. So what you're going to do is you're going to take two vials. You're going to fill each vial with approximately the same number of drops of the gold nanoparticle solution. So here I'm going to take the drops. I'm going to add to those about 8 drops. Okay, put that down, and we're going to the other vial, we're going to add 8 drops. So we've added 8 drops. These should look pretty identical. You know, it might be slightly different amounts, but you really want to be able to see the color. Now what we're going to do is we're going to have the volunteers, or not the volunteers, we're going to have the guests pick their sports drinks, and then they can start doing drops. And what we want them to do is using a pipette, and we want to make sure that we keep the pipettes solely for each of the given electrolyte solutions. We'll have a whole box there, so if they end up getting contaminated, we can just throw them out and go from there. We're going to have them open the electrolyte, pick an electrolyte solution. Here we're going to start with our Gatorade. And what we're going to do is keep adding this. We're going to add it until we start to see a color change. So what I'm going to do here is I'm going to take our Gatorade. I'm going to start adding this drop-wise. Add a drop. I'm going to twirl it a little to give it some time to interact with the gold. Do it again. If you want to see about a color change, we can put it next to our standard to help you see if a color change is taking place. We're just going to continue adding this. So in this instance, I've added 6. Now we can see that this is darker than our original gold nanoparticle solution. Now what we're going to do is we're going to test our other electrolyte solution. In this case, it's going to be Pedialyte. We want to remember how many drops were added to the Gatorade solution so we can compare. So we're going to do the same thing. We're going to fill a pipette with our Pedialyte. And we're going to start adding it in the same way. See if that has changed. And in that instance, we see a change here. What we want them to do is they count the number of drops it takes to see a change, and based on the electrolyte solution that takes the fewest drops, that will equate to having more electrolytes in the solution. After you're done with the demonstration, we want to clean up what we've done. So we want to make sure that we clean out the vials. To do that, we want to use deionized water, and it has to be deionized water. We're going to dump the solution with the electrolytes and the gold colloid into our waste beaker, and then we want to wash out with our deionized water. We want to make sure we can get as much of whatever was in there out of there. We want to just squirt water in there twice. Let that dry. We're going to have a whole case of vials, so it'll give you some time to let them dry before using them again. You can just put them on a paper towel to dry and let them dry. So we'll have probably about 100 vials or so. So we will have to wash them throughout the time, but there will be enough there for you to use that should be dry. For the vial that contains the nanoparticles that are used as our comparison vial, we'll just leave that the way it is. The pipettes, if they get contaminated, you can just throw them out. They're not worth washing. You're going to get questions from people visiting the booth is, how is this nanotechnology? You want to talk to them about the fact that we're using gold colloid or gold nanoparticles. They're going to look at the solution and say, how is this gold? And we want to tell them about the size of the particles. In this case, they're going to be between, I think, 13 and 15 nanometers in size. And when something is that small, it has different properties. In this case, because of the size of the particles, how they interact with light is different than how bulk gold or gold that you would get at a jewelry store will interact with light, giving it a certain color. As the particles become larger, which they do from interacting with the electrolytes, their color is going to change, and that's how we can use this as a sensor. So in this instance, when we add electrolytes, those electrolytes are being added to the solution. They're clumping together the particles, and as they become closer together and clump, their color is going to change. And what we see is a change from the color we start with, which is a reddish purple, to a more purple color, and that's because the size is getting larger. So I've mentioned the fact that these are used to test things such as viruses. The way it's tested is in the same fashion. What we do with the gold nanoparticles are we add a linker onto them, something such as a biological molecule. Biological molecules such as, say, RNA or DNA, or something that will interact with, say, a virus. When that interacts with the virus, it's going to help bring together the particles, and we'll see a color change there as well. So while what we're doing at the table here is not how gold nanoparticles will be used as a sensor, we wouldn't use gold nanoparticles as a sensor for electrolytes. It's using the same idea that as we add something into the solution, it's going to bring those particles closer together, and we're going to see it change. So this is a quick and safe way to show an application of gold nanoparticles as sensors. You're going to get some questions about why would we use gold nanoparticles as sensors for electrolytes and sports drinks. And as I've said previously, we're not really going to do that. But you're also going to get some questions about, isn't this a really expensive way to test for electrolytes? What's interesting to note is that you can ask them, how much do you think the gold costs in this vial? And this is fractions of a penny. Even with gold skyrocketing in cost, this is fractions of a penny. Turns out that the vial is considerably more expensive than the gold in here. And that really is a way to connect for them the idea of how small nanotechnology is and nanoscience is and the scales that we're working on. The fact that this is so inexpensive in terms of what it costs to do this test. And they may say, well, are they going to use this for electrolytes in the future? Well, no, there's other ways of doing it that's a little easier for these purposes, but the idea gets across, this lesson gets across the idea that nanotechnology is small, and that when we're dealing with things on such small scales, it can be a lot less expensive.